Hi, my name is Lori Williams. I am a software engineer on the Streams for IBM Cloud Private for Data. I'm going to demo how you can monitor the status of an instance of the Streams add-on to determine if the instance is healthy or if an error occurred. First, I'm going to describe the add-on topology, then do a short demo. An instance of the Streams add-on is comprised of multiple Helm charts. The Streams instance Helm chart creates and starts an instance of the Streams runtime environment for running streaming applications. The Streams instance chart exposes two Kubernetes services. An SWS service provides access to the REST API and Streams console for monitoring and submitting jobs to the instance. JMX service provides access to the Streams JMX APIs that can also be used for monitoring and submitting jobs to the instance. The Streams runtime environment is composed of a set of management services interacting across one or more management resource pods. The instance compute resources are created when a Streams application is submitted to the instance. The Streams instance has multiple external dependencies. It requires a persistent storage for an application cache repository. The application cache repository caches the application bundle for application high availability. The Streams instance requires a Zookeeper server to manage and store configuration information. You can set up an external Zookeeper for production environments, or you can use an embedded version of Zookeeper for a development environment. If you use an external Zookeeper, you must set it up before provisioning the add-on instance. If you use an embedded Zookeeper, this will be installed as a Helm chart, which I will talk about shortly. Streams supports checkpointing of application state to enable guaranteed tuple processing. The Streams instance uses Redis as its checkpoint store. Using checkpointing is optional. If a user wants to use application checkpointing, they must set up a Redis instance and supply Redis when provisioning the add-on instance. Streams build service chart creates and starts a build service for building Streams applications. The build service chart exposes one Kubernetes service. The build service provides access to REST APIs for submitting builds to the service and monitoring the builds. The build service is composed of build pod and multiple builder pods. The number of builder pods are configurable and will be created as builds are submitted and removed after the build completes. The build pod is the orchestrator of the builder pods. It allocates and manages the pool of builder pods that will perform the compilations. This also hosts the build service REST API. The builder pods perform the actual compilation and generates the build artifacts. A builder resource lives for the life of a single build and then is disposed of and replaced as necessary. The number of builder resources are configurable. The build service chart requires some persistent volumes. There is a persistent volume claim called build that's used to store build-related data such as build archives, compile results, and build artifacts. There is a persistent volume claim that is optional for builder pods, and if specified, it is used to store additional toolkits required when compiling applications. The external persistent volume claim is used to store external libraries required to compile applications. For example, the Anaconda package is installed to this persistent volume claim when the build service chart is installed. This is where the bulk of the time is spent when provisioning. A Kubernetes job is kicked off at provision time to initialize this PVC. As I already stated, if you are working in a development or a non-production environment that does not require high availability, you can opt to use an embedded Zookeeper instead of setting an external one. If using an embedded Zookeeper, the Streams add-on will install the Zookeeper chart, which sets up a one-node Zookeeper ensemble. The Zookeeper chart has one external dependency. There is a persistent volume claim to store Zookeeper configuration data. Now I'm going to go on to the demo. First, you need to launch the add-on catalog and find a Streams tile. You'll click on the Streams tile and select to provision an instance. To save time, I already entered the necessary options. In this case, I'm going to provision with an embedded Zookeeper. Now that I've specified all the options I want, I'll click Next, and then I'll click Provision. The provision progress page is displayed briefly, then you will be redirected to the View Details page for the instance being provisioned. On the View Details page, you can monitor the status of the Streams add-on instance. When the provision is in progress, the overall status will be pending. You'll also notice that there's some Helm status section added to the page. The Helm status section will be shown anytime an action is taken on the add-on instance that requires the values of the Helm release to be updated. In this case, we're provisioning the add-on instance. From the statuses, you can see that the instance Helm status is waiting and the build status Helm status is also waiting. This is because I selected to use an embedded Zookeeper, and the instance chart requires the embedded Zookeeper Helm install to be completed and ready before it can start the installation. Once Zookeeper is ready, the Helm release will proceed. When the Helm install completes, you will see that the Helm statuses are removed. The instance status is set to running, but the build service status is still installing. As I described in the topology presentation earlier, when the build service is provisioned, it will start a Kubernetes job to initialize the external persistent volume claim. Depending on your environment and the type of storage used for the persistent volumes, installing the external libraries can take anywhere from 10 to 60 minutes. When the provision completes successfully, you will see the instance status will be running and the build status will be ready. This means that your add-on instance is ready to begin submitting Streams applications to build, and then once built, to run the applications. I showed you how to monitor the status of the instance when provisioning. So how do you see the status after it's provisioned? You can monitor the status by first navigating to the My Instances page, then select the Provision Instances tab. Select the service instance you want to display the details for, and click View Details. There are other possible statuses you may see on the View Details page. Here is an example of what it might look like if the provisioning fails. The statuses for the add-on instance are documented in the IBM Cloud Private for Data Knowledge Center. See the Troubleshooting Add-on topic for the Streams add-on. You can also see Architecture topic that I talked about earlier. This concludes the demo.